Hi, in this lesson we will discuss about the symbol table and dictionary handling functions in Autolisp. What are the symbol tables? Symbol tables are used to store non-graphical information in a drawings database. The symbol tables that exist in the drawing database are the app ID or the registered applications. These are mainly used for extended data, blocks, dim styles, dimension styles, layers, line types, text styles, named user coordinate systems, named views, and named viewports. All of these are not case sensitive, so you can use them in your code even in the lower case. So there are three major functions in the symbol table to access the information or search or retrieve the data. First one is the TBLSEARCH. This function searches a symbol table for a symbol name. Syntax for that is just TBLSEARCH, the table name, any one of these, and the actual symbol name. So, for example, we are searching for the style with the name of standard. If it is existing, it should give us the list of these results with the type, which is the style, the standard, the name of the style, and some other information like the text height and the text string. The next function is TBLNEXT. This function finds the next item in a symbol table. So the syntax for that is TBLNEXT and the table name, and there is this optional parameter or argument called rewind. I have a note here that this is an optional argument. If this is present and is not nil, the symbol table is rewound and the first entry in it is retrieved. So in our example here, we specify the rewind argument as true. Basically, we are looking for the next layer in the database, this dictionary database. So it gives us the results, the layer, the line type. So these are all the breakdown of the layer information, the next layer in the dictionary is a symbol type, which is a layer, is the symbol name. Layer 0 is the flag, the color number, which is white, and the line type is continuous. The next function is TBLObjName. This function returns the entity name of a specified symbol table entry. Syntax for that is TBLObjName, then the table name and the symbol. It is about the same syntax as with the TBLSEARCH. And so we search for the block and then the block name here, the light block name. If it is found, then it just returns the entity name. So the difference between the TBLSEARCH and the TBLObjName is that the OBJName just returns the entity name while the TBLSEARCH returns the list. So that's about the functions for the symbol tables and dictionary handling. We will further explore these functions in the next video. Hi guys, we've already learned TBLSEARCH function from the previous video. In this lesson we will create a program to see how it works. So the objective of the program is to replace the text style. Let's examine first what are the styles in this drawing. So we can see that by typing the style, and we can see that we have here 5 styles. So let's create a simple program to substitute the style of the text. Let's call this one as a define. Just put this one into an Autolisp mode. Define C update style. Okay. So assuming that we are going to use the architect style, let's just hard code it for now. New style, say architect. Okay. Then we will ask the user to select a text that we're going to replace with the architect style. So we will use the car end cell, and then prompt the user to select a text to replace with the style. Okay. One more. Now let's get the property of this text. Set Q. Let's make it TXP for properties, and we will do the end get of the text. Okay. Now let's create another variable that will hold the value when we substitute the style of the text. So let's say txp new. We will use the substitute command, and which particular list we're going to substitute. It would be the style of the text, which is in this case we'll do the cons 7 new style. This will be the new style. Then we will replace the old style, which is in the list. It is the association list of 7 of the TXP, and we will do it in the TXP variable. Okay. Then we are going to issue the entity modification entmod to update the list txp new. Okay. Then we will issue the end upd so that the updated entity will be regenerated in our drawing. And then just type the princey. So let me just break it down further. So the first line, we are just actually hard coding the new style, which is this one here. The reason why I chose this one is because if I list down this text here, the style is standard. Okay. So we will replace this one with the architect style. That's why we hard coded it as in the new style variable architect. And then we select the text. So if you remember the end cell, let me just show you the end cell. Select the object. It gives us the entity name and the point, right? So we are only interested on the entity name. That's why we use the car. Next, we are going to do the end get to the entity name, which is in this case to get all the drawing definition data. Okay, so this is what we have for TXP. As you can see it now, we create a list of style which is con7 of the architect, and we are going to replace the ASOC7 of TXP. This is the one. So basically we are replacing this text. We are replacing the text with this one here, the architect. Okay, so this is the definition data of the text. We will just be replacing this one with the architect, and then we update it, and we issue the end mod to update the data definition. Then we update it. All right, so let's try this program. Let me just save it first. Save it to Autolisp. Let's say update style.lsp. All right, so now if we load that file, load, see, always load. Okay, so now we have the command update style. Okay, let's run it. So select a text to replace with a style. There you go. Nice. So if we list this one, it should now be architect style. Okay. All right. Now, how are we going to apply the TBL search? Let's create a new function. Define C. Let's say update style 2. We are going to copy exactly all of this, except that instead of hard coding it, we are going to use the getString function by prompting the user to enter the new style. Okay. And then what we're going to do is we have to validate if the style that the user enters is valid, or if it exists in the table, the style definition. So this is what we're going to do. If TBL search, this now TBL search come into play, then we search by style, then new style. Basically we're checking if it exists. If it does, then we do the program, then we execute all of this. All right. Otherwise, if it doesn't exist, we'll just prompt the user. Style, the new style or the style that the user entered is not found. Okay. So that's just about it. But before we execute this one, let's create our own style. So let's say we create our own style. Create our own style, new style. Let me call this one italic bold. Okay. Then the font style should be bold italic. Yeah, we can use the Times New Roman, and let's make the width factor 2 so we can see the effect right away, and apply. So now we have here our new style. Okay, that's the one we're going to use. Now let me just load the program. That update style. Okay, update style 2. Oh, we haven't saved it, that's why. Let me save this one and load it again. We have an error here, malformed list. Let's check it out. This is okay. This is okay. We missed the closing parentheses for the if statement. There you go. This is okay. Yeah. So save it. Load. Nice. Now we have the update style 2. Let's execute that. So we are now prompting the user to enter a new style. Let's try first if the user type in something that doesn't exist. Let's say, whatever. Style whatever is not found. Okay? So our validation is working, which means it tries to search from the style database and it wasn't found. So we just provided this message here. Now let's try it again with the valid style, italic bold, and enter. Now we ask to select the text to be replaced with. Let's try this one. There you go. So that's just about it. That's the use of the TBL search. Alright, give this a try, do some tweaking however you like it, and see how it goes. In the next video we're going to I'm going to show you the TBLNEXT function, and I'll see you there. Hi guys, welcome back. In this tutorial we're going to explore the TBLNEXT function. We will create a simple program to display all the layers in the drawing. So as mentioned before, it's always good to have this comment on top of the code with the date and your name, and also the description of the function, just so when you get back to this program, let's say a few months or a few years from now, by just looking into the description, you know right away what the program is meant for. Okay, so let's start to create the program. We'll call this one as display layers. First, we create a variable called flag and set it to true. We will be needing this flag because we're going to loop through the drawing database to see all the layers. Now let's create another variable that will hold the list for the TBLNEXT results, and we use the argument t for true. So when this is present, it will rewind to the first layer in the database. If you review the previous videos, the tutorial, the theoretical explanations, you can see it there. So before we continue, let's examine first what's the output of the TBLNEXT layer true. Let me just copy this one and paste it here. So what do we have here? 0 is the symbol type, which is we are exploring the layer database. 2 is the symbol name, which is layer 0. Currently we're in layer 0. 70 is the flags. 62 is the color, which is color white, 7. And line type is continuous. Okay. So now let's continue working on our program. We are going now to loop through the drawing database. So while flag, which means while true, we will continue processing. So let's now create another variable that will hold the value of the layer name. So based on these results, we are only interested in the association list number 2, which is the layer name. Okay, so let's create a variable called lname, and we are going to use the CDR association list up to in the lprop variable. Okay, so this lname now will be this one here. Okay, now let's do another validation. If make sure that the lname is not nil. Okay, make sure that the lname has a name in it, not a nil value. So if there's a layer name found, then we just prompt the user. String cat layer name, then the layer name, the L name. Otherwise we'll set the flag to nil. So we'll exit the loop. Also, we have to execute the TBLNEXT again, so that it will move to the next layer without the T, without this T. If we have the T, it will always start with the first layer name, so we don't need this one. Okay? Just put the Prince here for a clean exit. Alright, so let's review our code very quickly. We just initialize a variable here. Then we store the TBLNEXT list results into lprop. We loop through the drawing database while it's true. Get the layer name. If it's not nil, then display to the user. If it's nil, then set the flag to nil so that it will exit the loop. So every loop we have to execute the TBLNEXT again so that it will go to the next layer and so on. Okay, so let's save this one and let's call it the display layers.lsp and load it. Display layers. Oh, sorry. Okay, always load it. Then display layers. Let's see how it goes. Nice. So these are all the layers we have. Okay, we check the layers here. These are all the layers, right? And our code exactly shows the same list of layers. Very nice. Alright, so that's about it for the TBLNEXT function. Try using this on your own. Maybe you can come up with some other ideas to, let's say you use the style instead of layers, or some other symbol types like line types or views or viewports, and see how it goes. Alright, I'll see you in the next video.